Welcome to part 2 of section 1.8. To continue with this idea of this continuous functions, we have some properties. If f and g are continuous at a and c is some constant, then these functions are also continuous at the value of a. F plus g, f minus g, that constant function, that constant c times f, the functions f and g multiply together. F divided by g as long as g of a is not 0. And a couple more properties. If f and g are continuous on an interval, then so are the functions f plus g, f minus g, c times f, f times g, and as long as g is never 0, f divided by g. Any polynomial, as we said before, is continuous everywhere, so it is continuous on, this means the real numbers. And any rational function is continuous wherever it is defined. That is, it is continuous on its domain, that being for any rational function, which is the reason why before when we did example 2a, I said that the denominator cannot be 0, and that's the only location of where it can be discontinuous. It's because it's a rational function. So to continue along with the examples from this, we have example 4. We want to find the limit as x approaches -2 of x cubed plus 2x squared minus 1 divided by 5 minus 3x. This is a rational function. So because of this, its domain would be the values of x such that x cannot be 5/3. Because if it was, that denominator would be 0, and that's not good. -2 is not 5/3, so we could just plug this in. So this would be equal to whatever the value of f of -2 is. So that would be, in our case, -2 cubed plus 2 times -2 squared minus 1 divided by 5 minus 3 times -2. We would get for this the value of -1/11. So when it comes to trigonometric functions, we could see that for the sine of theta and cosine of theta, as theta approaches 0, the point, the cosine of theta comma sine of theta, approaches the point 1 comma 0, right? That being from the unit circle, which looks something like this from trigonometry. We would have a right triangle, right? We're at this point right here. We are referencing that cosine of theta, comma the sine of theta. And as long as theta here is approaching 0, so we get closer and closer to the x-axis, the point starts going to where cosine of theta approaches 1, sine of theta approaches 0. Thus, the limit as theta approaches 0 of the cosine of theta is 1. The limit as theta approaches 0 of the sine of theta is equal to 0. So these are also then continuous at the value at 0. Since the tangent of x is equal to the sine of x divided by the cosine of x, tangent of x is continuous except for when cosine of x is equal to 0. Right, and we could kind of see that happening in our unit circle when we have ourselves right here, which is at pi/2, and also at 3 pi/2, and so on and so forth. So every odd multiple of pi/2, as we could see in our tangent of x graph down here. The function types that are continuous at every number in their domains are polynomials, rational functions, root functions, trigonometric functions. So for more examples, example 5, on what intervals are each function continuous? A here, f of x is equal to x to the 100th power minus 2 times x to the 37th plus 75. This would be a very pain in the neck to try to graph, but this is a polynomial. So this is continuous in all real numbers. So actually, let me write very quickly that this is a polynomial. It is continuous on all real numbers. So negative infinity to positive infinity. So g of x, x squared plus 2x plus 17 divided by x squared minus 1. This is a rational function. And so because of that, we need to look at this where for our domain, denominator can't be 0. And that occurs when x, all the values of x, such that x cannot be positive or negative 1. So then we get 1 minus 1 and get 0. So x can't be positive or negative 1. So that means we are continuous. It's on several intervals, negative infinity to negative 1, negative 1 to positive 1, and positive 1 to infinity. And then finally, h of x is equal to the square root of x plus 1 divided by x minus 1 minus x plus 1 divided by x squared plus 1. So to look at these different functions, right, since we have 3 different parts right here, for the square root of x, this domain is over the values of from 0 to infinity. For the second one here, this being rational, this denominator can't be 0. That only happens when x cannot be 1. And for this one, again rational, denominator can't be 0. But luckily for us, the denominator never equals 0. So this is actually continuous in all real numbers. So due to each of these, applying it all, then since we have the whole thing as our function h of x, this entire thing is continuous on from 0 to 1, including 0 but not including 1, and from 1 to infinity. So that's part 2 of this section 1.8. Be on the lookout for the third part. Thank you.